So, welcome to our channel Electronics on Wheel and thank you for your support. So, as this channel has come up with all your requests which you have made, so many of you have asked us to create the videos in Hindi. So, it was not possible for this channel to come up with the Hindi videos, as you know that there are many people who are from different regions. They want only videos in English only. So we have requested to one of our friend that his name is Parul Singh. So he is working as a car technician since 20 years, and I will give you this link in the description box and the comment box also, so that you can subscribe his channel. Please support him to get the real exposure on vehicle, and let him give the feedback whatever you have. If you like his content, please subscribe, like and comment. And his channel name is the car mechanics. So let me start today's topic, that is made based on the one of our subscriber has requested that could you please make the videos on cost saving ideas or for the wiring harness. So he has requested many times, even on telegrams and the comment box also. So we have come up with this video. So let me start without wasting time. So we will have two different approach for the cost saving ideas on wiring harness. So first one is the design consideration. When you are designing your wiring harness schematic creation and other wiring diagram creation, then you take the consideration of the costing. So this is the first approach to save the cost on the wiring harness development. And second approach is the manufacturing process. So on supplier end, once you give the 2D drawing to the supplier and supplier is creating the wiring harness, so he has many process like wire opening, crimping process, pre-assembly process, then assembly process, final assembly process, and he has to procure the components from the different third party supplier, like raw material cost, and you know uh, he will be having some manufacturing cost for the labor, equipment, assembly and testing. So these particular cost comes on the manufacturing end or supplier end. So this particular cost we will take in a one separate video, but today we will understand some design consideration where you can save your cost on the wiring harness, and we will try to understand how you can create those ideas on the wiring harness so that you can save the cost. So let's start with the design considerations. The first thing is the reduction in the length of wire. What does it mean? Suppose this is my one end of wire and second end is this, and earlier I was using the 2000 mm wire of 1 square mm, right? But after realizing the routing, position, and other factors, that I can manage in 1500 mm itself, 1 square mm. So, what does it mean? 2000 to 1500. So, you have saved around 500 mm of 1 square mm. So this is the condition. We will try to see how you can deal with this type of situation, and you can identify in your wiring harness. Second point is wire cross section reduction. So earlier, before, what you were using, suppose 2.5 square mm wire you were using, okay, for one particular function. Any particular function you can take, suppose like headlamp, I take a hypothetical example I'm taking. But after realizing the current requirement, and you come to conclusion that 1.5 square mm is sufficient for this headlamp, because the current demand from the component is like that you can manage with the 1.5 square mm. So here you can see 2.5 square copper wire would be more costly compared to the 1.5 square. So this is the one thing. But you have to maintain one thing whenever you are taking this type of decision in cost reduction, that you should not compromise with the quality. So quality you have to maintain. So one example, suppose in before you were using the 2.5 square mm and there was some inrush current or transient current, because of that you were using the 2.5 square mm, right? But you have, when you are reducing this wire 1.5 square and you have not taken into the consideration inverse current or transient current, so what will be happening, that during the inverse current or the transient current, this particular 1.5 square wire will not be sufficient, and during that your wire will be burn out. So in that case your safety will not be considered in consideration, and your quality will be affected. So this is what I'm trying to say here. Whenever you are making the decision of cost reduction, then you have to take care of the quality. Then we have the splice optimization. So I'll give you one example of splice optimization. Let me clear out. So you have one component, suppose you have taken this is from fuse, suppose. Then you have the two component, so component A and component B. So from here you are taking 2.5 square wire, here you are taking 1.5 square and here you are taking 1.5 square okay. So and you are giving for this particular power supply you are giving, this is the splice, okay, for both the components. So if this particular length from here to here is around 1000 square right, so from this 1.5 square this will be from here to here, this would be, suppose I take 500 and this is also my 500, right. Till here it is 1000 square and I take here to splice to here, this is 750 and this is 250. So my question here, that splice position you have to keep in such a way that your 2.5 square wire length should be less compared to 1.5, because 1.5 square wire cost would be less compared to 2.5 square So suppose if I keep this particular splice, rather than 750 I keep it 250 and I take this 500 till here, so it would be around 2, suppose I take 750 and here it would be 750, okay. So you have to take care into the consideration that how you can reduce the length of the bigger cross section of the wire, okay. We will try to understand this particular example in the coming slides as well. Then coming to the fuse optimization, we will see how you can use the one fuse for the two function. So there are two function like horn and the headlamps, so can you combine those two function into the one. So that we will see. Then we will see the material cost, the supplier, you might be having different supplier for the same connectors, so which supplier you should use so that your cost can be reduced. Then selecting the right wire, so you might be having different wire type according to the standards. So according to the JASO, you have the AV, AVS, AVX, right? So which type of wire you should select. Then selecting the right connector. So you have the waterproof connector, hybrid connector, non-hybrid connector. So which type of connector you should select on which condition. Then right insulation. So right insulation means that you have the requirement of clothing, that suppose you're routing your wiring harness is going through the cabin, and there the clothing is sufficient for insulation purpose or protection, but you are using corrugated tube or some other flex wrap, so which is not required, so you are externally adding extra cost. So these type of things we will see. So first we will see the reduction in the length of wire. So first point we will see the fuse. So my fuse box suppose is here and my battery is also here, somewhere here I taken. So I give one example. So your fuse box, if suppose your fuse box is here, then your battery should be also in this side only. Your packaging of battery should be in this side only. If you are doing battery package this side and your fuse is this side, then your routing length would be more, right? Similarly, you can see for the different component also. So suppose one component is placed here and you are taking your routing in this way. There are two way, one is this and second is this. So in one way you are getting 200 length, but in the second way you are having only 1500 length. So which one you should choose? You should choose, of course, the 1500 because you can reduce the wire length, and wire length if you are reducing, so then you are ultimately reducing the cost of the wiring harness. Then selecting the inline connector and the joint connectors. So joint connectors or inline connectors should be selected in such a way when you are passing your wires through the joint connectors, so it should have the less length. So suppose my this is my body harness or passenger harness or cabin harness, this is my engine harness, right? And I'm taking one inline connector here. So when most of the component are in this side, then you should route your wiring harness from this inline connector. You should never use this, suppose you also give the inline connector this side also. So you have to take care these type of things when you are placing your inline connector or you are routing your uh, inline connectors, the routing your bundle you are creating. Then for the ground also the same thing as I told you in fuse. So suppose my ground requirement is here, so you should ask from the other CFT members or other cross-functional team, the BIW team, that my ground requirement is on this point. I do not want the ground instead on this point, so that you should have the less length for this particular thing. So you always have to discuss with other cross-functional team to discuss all these points, because this is not dependent only you. It is like dependent on other teams as well. Then location of the component, as I already told you. So packaging, this called its packaging of the component. So suppose your power distribution or fuse box is here and you have placed your battery in this front, then of course your length would be more. You should always ask the packaging on this place so that your length would be less. So this is how, these are the some of the factors or some of the cases where you can see the possibility of reduction of the length. So moving to the wire cross section, that is our second point. Moving wire cross section reduction. So wire cross section reduction, what does it mean? So suppose you have the one example I'm taking, you have your horn relay. So I already told you in many classes that the horn, whenever you are using the relay, any relay, then the contact side would be on a higher current and the coil side would be on very low current, right? So low current would be in milliamps, but high current might be in the 10 amps, 15 amps, depending on the load. So if you see here, if you are giving 0.75 here also and 0.75 here also, then there is no point of using the relay, because you are not saving what can be saved. So suppose 0.75 is the requirement of this horn as per its current requirement, but I'm very much sure in the coil side you can use 0.35 itself, because the coil side current requirement is very less. Okay. So these type of things you have to think, and you have to find out these type of opportunity to reduce the costing of wire. Then CSC after the fuse, so we will see this point as well. So suppose this is my 15 amps of fuse. So there is a one thumb rule: if you are using 15 amps of fuse, then you can use the 1.5 square mm, but you are not required to use the more than 1.5 square. Suppose you are using 2 square mm, right? But 2 square mm is not required here. 2 square mm wire is not required here. So you can reduce this type of wire cross section wherever you see the possibility of wire cross section reduction. Then CSA on the splice. So you have this splice, so definitely when you are taking this 0.75, and here also you are taking 0.75, but you will see if I'm taking here 10 amps, so definitely my current will be divided here, and it would be sum of, suppose here I1 and here I2. So this I would be I1 plus I2, right? So in this case, this 0.75 and this 0.75, I am very much sure it is not required. You can reduce this particular wire cross section to 0.5. But you just check out the inverse current or transient current, how much transient current or inverse current is there, then you can reduce. So these type of, this is splice here, this is splice, so these type of situation you will be having, and you can work upon on this type of wire cross section reduction based on the current requirement. Now moving to the splice optimization. So in CAPEX itself, in capital harness XC, if you go under this workflow, you will be having one option that calls the splice optimization. Once you click on that splice optimization, so as I given you one example of earlier also, so this is the my splice position. Okay, so this splice position, suppose used for the power. Okay, power signal we have used this splice, and we are taking here, it is 1000 total. So here it is 500 square sorry, not square I'm sorry, 500 this is 500 this one is 500 and here also this is 500 okay. So and this one you are using the 2 square of wire, so it's better to reduce the length of 2 square so if you shift somewhere here near, so 250 suppose you, then you can, of course you will increase the length of this particular wire, that is suppose 1.5 square but still it would be, if you take in terms of costing, then it would be less costly. So you have to think in that way, uh, in and around that, how you can reduce the length of the wire or splice, so that you can reduce the costing of your harness. So one more example, if I take, suppose here this is my A component, this is my C component, this is my B component, and this is my 1000 and this is my 1000. One simple example we will take, this is 1000, right? So all are 1000. So suppose I am using here 5 square here also, here I am using 2.5 square here I am using 2.5 square So suppose if I shift this particular somewhere here, right? So you will be, suppose I shift here 500 this splice, so you will be saving this 5 square for 500 square Of course this will be 2.5 square will increase, but 5 square wire you can reduce for 500 square 500 so this type of situation you have to see, and you can optimize the splice as well. We will discuss this, these are the insulation, so we will discuss these are how you can improve the on insulation as well. So fourth one is the fuse improvement. So in fuse improvement, what is the situation? Suppose I take two options. So suppose you can see here, these are the fuse rating, these are the color, and these are the circuits. So if you see, these are the these different functions are taking different fuse. So here I take 5 amps of fuse, here I'm taking 5 amps of fuse, right? And this is for the HVAC ignition ignition and this is for the rain light sensor. Okay, rain light sensor. So suppose if I combine these two functions into one, so what I have to do, I will remove this fuse. So right now you are taking suppose one example 1000 here also you are taking 1000 right? So you are taking 2000 combinedly. But if you are using one splice, and you are just take you are just removing this fuse here, and through the splice you are taking the power supply from the same fuse. for rain sensor also and HVAC also. So you are saving one 5 amps of fuse, and second thing, you are saving this particular length as well. So you have to think about that how many functions you can combine, and you have to take care in this situation, because suppose if this one particular fuse is blown, what does it mean? That both of the functions will be gone. So you have to be very careful when you are selecting or you are doing this type of fuse optimization. Suppose you should never share your fuse with the airbag. Airbag is a very sensitive function. You should not use airbag fuse with other you know other functions. So airbag, ADAS functions, these fuses should never be shared with other function. So functions which are not very critical, those functions you can share with each other, and this is how you can save the your mm, your costing. Now coming to the material cost. So one example I take, one connector I am taking from the Yazaki. The Yazaki is the manufacturer, or you can take Aptiv. Okay, so Aptiv, you can take the Molex as well, and you can take other T as well. So these are the suppliers. So this two pole connector I am taking from four different suppliers. If you see the costing of the uh, all these four supplier would be different, or some local manufacturer you can also take. So it would be very less in comparison of these four big suppliers. Okay, so in this condition you have to think about this thing, that can I use the local made connector in this case? Suppose if from Aptiv, Yazaki or Molex, if one connector is coming of 5 rupees, then for local manufacturer you can manage with the 2 rupees as well. So you have to think about whether whatever local manufacturer has produced the connectors, are they tested already, are they have supplied to some other OEM, or they are working fine or not. You have to think in that way, and on that basis you can reduce your cost on the wiring harness. Moving to the selecting the right wires. So you know that there are many different standards, like DIN standard we have, then JASO standard we have, then we have SAE standard we have. So DIN standards is a European standard, JASO standard is a Japanese standard, and other standard as well. So if you see the DIN standard, we use the FLRY A, B, and W. So you have to think that whatever wire you are choosing, whether you are choosing the right wire, because the costing of the wire would be different for JASO, DIN, and the other standards as well. So in that JASO also, you might be having some different type of wires like AV, AVX, AVS, CAV. So these wire type would be having different costing based on the temperature range. So suppose this particular wire is only withstanding on 85 degree centigrade, and AVX is standing with the 125 degree centigrade. Suppose you are using the different type of wire on different location, then it is not making any sense, right? Supposing you are using in passenger compartment, right? So passenger compartment doesn't require the 125 degree centigrade or 105 degree centigrade. If you are using for the 85 degree centigrade of wire, then it is fine for the cabin or passenger, right? So you have to think in that way, that whether whatever wire you are selecting, AV, AVS, AVX, right? So whether you are selecting the right wire based on the costing or not. If you are selecting any wire at any condition, then it is not good practice. So you have to take care of that thing as well. Then selecting the right connector. So as I told you, there might be two different scenarios. The you will be having the requirement of non waterproof connector, where you do not require any uh, you know you do not have any requirement of waterproof connector where you like passenger compartment, right, or inside the cabin or inside the instrument panel, right. So there you do not require the waterproof connector because there is no chance of water entering. So you can use the water non waterproof connector. But when you need the waterproof connector, then only you should use the waterproof connector where you have the fender and bumper area, right. So these type of condition or location you should use those type of connectors, right, because non waterproof connector costing is less and waterproof connector costing is higher because they will be having seals and rubber seals, matte seals, many things are there, right, in waterproof connector. So of course the costing of waterproof connector is more. So you have to take care based on the, if you want all these description, I have already created some of the videos where you can see where you have to use what type of connectors. Then selecting the right insulation. So in insulation also there are different type of insulation like corrugated tube and heat sink tube, then sleeving is there, then self wrapping woven sleeving is there, extruded pvc tubing is there, expandable braided sleeving is also there. Then you have the clothing also, tape also, only tape is required. So suppose you do not require the corrugated tube in the passenger compartment, right, and you are using that one, so this is the extra cost you are putting on that. You can manage with the clothing itself. So you have to think in that way that am I using the right insulation for this, so that I can reduce my cost. Okay, so I hope you understand all these scenario where you have to see all these points when you are selecting different components of wiring harness, and this is how you can manage your costing in wiring harness. Second is comes as manufacturing process. In another video I will make what are the factors comes in the manufacturing process on supplier end, and how we can do some cost saving on the manufacturing and also manufacturing process also. If you like the content of this video, please like, subscribe and comment. Thank you for your time.